Good morning dear students. In this video I'll teach you a problem based on complex analysis. The problem is if Z1 equal to minus 1 plus I and Z2 equal to 2 minus 3I, then evaluate real part of iZ1 divided by Z2 minus I and imaginary part of Z1 bar divided by iZ2. So let's see the solution. We have our first complex number Z1 equal to minus 1 plus I. iZ1 means multiplying I with Z1. So multiplying I with Z1 means multiplying I with minus 1 plus I. So I with minus 1 gives us minus I in multiplication, and I multiplied with I gives us I square. And in the next line, iZ1 equal to minus I minus 1 because I square equal to minus 1. Also, Z2 equal to 2 minus 3I. Z2 is our second complex number. And Z2 minus I means subtraction of I from Z2. Now, subtracting I from 2 minus 3I means 2 minus 3I minus I, which will give us 2 minus 4I, because minus 3 and minus I are added to each other. Now we calculate iZ1 divided by Z2 minus I. Because to solve this real part of iZ1 by Z2 minus I, first we have to calculate iZ1 divided by Z2 minus I. Next we will see the real parts and imaginary parts of it. So iZ1 is minus I minus 1 and Z2 minus I is 2 minus 4I. So we can write iZ1 divided by Z2 minus I equal to minus I minus 1 divided by 2 minus 4I. Here our numerator is minus I minus 1 and denominator is 2 minus 4I. To solve it, we have to multiply both the numerator and the denominator with the conjugate of the denominator. So the conjugate of the denominator is 2 plus 4I. So we have multiplied both the numerator and the denominator with the conjugate of the denominator 2 plus 4I. So multiplying 2 plus 4I with minus I minus 1 will give us minus I multiplied by 2 gives us minus 2I. Minus I multiplied by 4I gives us minus 4I square. Minus 1 multiplied by 2 gives us minus 2, and minus 1 multiplied by 4I will give us minus 4I. So in the numerator we have minus 2I minus 4I square minus 2 minus 4I, the result of this multiplication. In the denominator we have, this is in the form a minus b multiplied by a plus b. So a minus b multiplied by a plus b will give us a square minus b square. So 2 square minus 4I whole square. 2 whole square minus 4I whole square. This is the calculation part of this multiplication. Now, further we can simplify this iZ1 by Z2 minus I as minus 2 plus 4 minus 2 minus 4I, because minus 4I square equal to minus 4 multiplied by minus 1, and minus 4 on multiplication with minus 1 gives us 4. So since I square equal to minus 1, so minus 2I plus 4, because 4I minus 4I square is plus 4, minus 2 minus 4I in the numerator, and in the denominator 4 minus 16I square, because whole square of 2 gives us 4 and whole square of 4I gives us 16I square. So in the next line we can simplify this as 2 minus 6I, because 4 minus 2 gives us 2 and minus 2I and minus 4I are added to each other, which gives us minus 6I. So in the numerator we have 2 minus 6I, result of this calculation, and in the denominator we have 4 plus 16, because minus 16I square means minus 16 multiplied by minus 1, as I square is equal to minus 1, and minus 16 multiplied by minus 1 gives us plus 16. So in the denominator we have 4 plus 16, which we have further simplified in our next line as iZ1 by Z2 minus I equal to 2 minus 6I divided by 20. 4 plus 16 equal to 20. Now we can see the real part of iZ1 by Z2 minus I is 2 by 20, and the imaginary part will be minus 6I by 20. So here we only need to find the real part of iZ1 by Z2 minus I. Real part means 2 divided by 20. 2 divided by 20 gives us 1 by 10. Hence, real part of iZ1 by Z2 minus I is 1 by 10. Next, we have to find the imaginary part of Z1 bar by iZ2. First, we will calculate Z1 bar. Here Z1 is minus 1 plus I. Minus 1 plus I whole bar means the conjugate of minus 1 plus I. Conjugate of minus 1 plus I is minus 1 minus I. Only the sign of the iota part is changed. Now iZ2 means multiplying I with Z2. So multiplying I with 2 minus 3I will give us 2I, because multiplying 2 with I gives us 2I, minus 3I square. Further, which can be simplified as 2I plus 3, because minus 3I square equal to minus 3 multiplied by minus 1 equal to plus 3, because I square is minus 1. So iZ2 equal to 2I plus 3. And Z1 bar is equal to minus 1 minus I. Now Z1 bar divided by iZ2 equal to minus 1 minus I divided by 2I plus 3. Again, we will solve this by multiplying the conjugate of the denominator with both the numerator and the denominator. So our denominator is 2I plus 3 and conjugate of the denominator is 3 minus 2I. Because 2I plus 3 is same as 3 plus 2I. So, we have multiplied the conjugate of 2I plus 3 with both the numerator and the denominator. Multiplying minus 1 minus I with minus 2I plus 3 gives us 2I. Minus 1 multiplied by minus 2I equal to plus 2I. Minus 1 multiplied by plus 3 gives us minus 3. Minus I multiplied by minus 2I gives us plus 2I square, and minus I multiplied by 3 gives us minus 3I. So our numerator is 2I minus 3 plus 2I square minus 3I, and our denominator is 2I plus 3 multiplied by minus 2I plus 3. So which is again in the form of A plus B multiplied by A minus B. Here our A is 3 and B is 2I. So this will give us 3 whole square minus of 2I whole square. So further, which can be simplified as 2I minus 3 plus 2I square minus 3I can be written as 2I square equal to minus 2 and minus 4I square equal to plus 4. So when we solve this, we get minus I minus 3 minus 2, because from here we get minus 2 minus 3 and 2I minus 3I is minus I, and in the denominator we get 4 plus 9, because 3 whole square gives us 9 and minus of 4I square means plus 4. So further simplifying we get minus I minus 5 divided by 13. So Z1 bar divided by iZ2 equal to minus I minus 5 by 13, or which can be written as minus 5 by 13 minus of I divided by 13. Hence the imaginary part of Z1 bar by iZ2 equal to minus 1 by 13, and here the real part was minus 5 by 13, but by the problem we only need to find the imaginary part of Z1 bar by iZ2, which is minus 1 by 13. Thank you.